Hello, my name is Dylan Holzman, and this is my lane detection program that I wrote in Python. It's going to run through a process of 9 functions, and then we're going to display different videos at the end here. So our main structure is going to be to load in the video, cut it in half, apply a mask, convert it to grayscale, black and white, blur it, edge it, calculate our median lines from our hue lines, and then display them on the original video. I'll explain that as we go. So we start with our camera where we load in our video, and you just do that with this simple function show frame using camera.read, and then we use OpenCV's IMShow to play that original video, and I'll show that here. So you can see from this video, there's about 50% of the frame that's going to be useless to us. The top half is not going to contain any information we need. And additionally, the left and right sides outside of the lane are not going to be useful to us. So we're going to use a mask and create a trapezoid here after we cut it in half. So I'll show you how we do that next. Using the functions cut in half and the mask video, we take the height and we cut it in half and then just take the bottom half of that original video. And then we want to create that trapezoid shape that filters out the unwanted space on the left and right. We do this with an original array of zeros and then use that to fill with a trapezoid. And this is the bottom left vertice, top left, top right, and bottom right. And these values just decide where the vertices sit. Like this is 60 in and 70 up. So I will show you the masked video now. So we took the original one, cut it in half, and we added this trapezoid to it. So the next step in our process is going to be to grayscale it and then put it to black and white. And the the OpenCV has a simple way to do this using the convert color function. So we just take the color and change it to gray here, and then for black and white, I wrote a simple conditional since we're only going to be analyzing 2 videos here. But if there were more videos or more brightness differences in the lane videos, you would want a dynamic system that can better create a threshold depending on the video's brightness. But for our case, we have 2 videos and we set a conditional of if the average brightness from the mean value from the grayscale, if it's less than 15, we're going to set the threshold to 60. And if it's greater than 15, we're going to set it to 150. And we do that with the CV2 threshold function. And then here is our black and white. So as you can see, so far we have gone from the original video, we cut it in half, added a trapezoid, and then we set it to black and white. I forgot to mention that we used the bitwise and for the mask, and this works basically by the trapezoid that we created earlier. We set the entire trapezoid to be white, and then we use a bitwise to compare the image to itself. And then anywhere that is white, we will replace with the image, and anywhere that is not white, we will set to be black. Okay. So after making the image black and white, we want to apply a blur to it so that the edges are easier to detect. And we do this blur by setting a kernel size of 21 and using OpenCV's Gaussian blur. The kernel 21 is the default size, and after messing around with this value, I found that this was the best for the edge function. It picks up the best using this size pixel blur. And then the edge function runs by setting a lower threshold and an upper threshold, and then using OpenCV's canny. And I found that after playing around with these values as well, the this is as optimized as I can get it to be using 50 and 150. So our next step here. So as you can see, we have gone from the original, cut it in half, masked it, grayscale black and white, and now we have our edges. So our next step is going to be to try and trace lines onto these edges to predict where the lanes are going to be. And we do that with these two functions that work pretty synonymously. So I'm going to explain the second one first, because then we call the first one later. So we start by defining these global variables. I'll explain that later, but first we have our hue lines, which is an OpenCV function that places the lines on the screen based on the edges that we've defined earlier. We open arrays for the left lines and the right lines. This is the left lane and right lane, and then we define where the center is. From the hue lines, we receive an x1, y1, x2, and y2. These are coordinate points for where those lines are going to be, the start and finish, x1, y1. And then from that, we want to calculate their angle. And we do that just with a arctangent of the opposite, y2 minus y1 over the adjacent. And then from that, we get an angle. And then we've defined our hue lines to be between 25 and 65. So if that angle that we found our line to be is between 25 and 65, and it is on the left side of the screen as it's below the center of the screen, so on the left side, we will say that this is a left lane and we will put the coordinates to that line in the left line array. If not, it is a right lane and we will put these coordinates in the right lane array. So now that we have our coordinates in our arrays, we want to calculate the median line from these arrays. And we do that by calling in the left lines that we've just calculated, and we run our calculate median line. So this is a good time to explain what that does. So we go up here and we bring in images and the lines, and we calculate the slope from that just using the difference slope formula. And then we have a simple conditional here at the end that says if the x2 minus x1 is 0, we're going to set all of them to 0 so that we don't run into a dividing by 0 problem. And then the next one is the intercept. We need to know where this line crosses the median, and we just simply rearrange the y equals mx plus b function to get that intercept. And then we want to pair the slopes and lines together. So we use this zip to make a tuple of the slope and line. Moving forward, we get to the median slope, and this is where we just take those hue lines and we take the median of them. So the one on the outside, one on the inside, and we find that median slope. And then same thing for the intercept. So now that we have a slope and intercept, we need to find where these coordinates are going to start and end. We do that with the y pretty easily. We start it at the bottom and we end it 200 above the middle of the page, pixels. The next one is for finding the x coordinates from the slope and the intercept. And this is just another rearrangement of the y equals mx plus b, where we use the start and where it intercepts, where we're solving for x. And then lastly, we just have a little else statement in case the line is vertical, we'll set x equal to x, and it will be filtered out anyways later. So now we have our coordinates for our lines, and that will go into here. But first, let me explain this part here. So this part is for if a line is not available. So when there are the dotted lines on the road, there's no area for the edges to pick up, and then there's no line to be drawn. So we are saying that the last or the left median line is then equal to a variable we're calling the last left median line. And this means that if there isn't a line to pick up, the new left median line is the previous left median line. and that is the same for the right side. Now that we have our coordinates and we are able to plot if there is not a line available, we use cv2.line to make our left line yellow with this RGB, and then the same thing for right using red. Okay, and lastly, I will just show you the process we went through really quick. We went from our original frame from the camera, and then we cut it in half, and then we used our half frame, put a mask on it. We masked it, converted it to grayscale, convert to black and white, and then we blurred it. Then we used the blur to find the edges, and then from the edges, we put the hue lines, found the median, and then we will plot the median hue lines. So here is our final product. And as I just described, we went from the original to the mask to the black and white to the edged to then the hue lines video. As you can see here, there's no right lane being detected because there's nothing here. So that red line stays where it was until it starts picking up these dotted lines again. And then we will display our second video. This one has a brighter hue to it. And at the start, there's a lens flare that causes the lines to go in a lot of different directions, and then it settles in. But this is from that dynamic or not dynamic, the conditional black and white I made. So this video is above an average of 15 in brightness. So the threshold is 150. And as you can see, that works pretty well with the edges on this video.